Good afternoon. It's been a wonderful conference so far. I decided to present on a topic which is very popular, but at a level which is a little more technical. Uh, I'll try my best to take everyone along me. I have simplified it. The objective is, by the end of this presentation, you would have intuitive understanding about how the three technologies mentioned on the screen work. Moreover, I'm going to lead you to some great resources. There are going to be a lot of QR codes, some demos. Also, I'm going to highlight some cutting-edge work that is happening in our part of the world in these fields. Okay? So let's get started. So if we want to achieve our vision of AGI, three things need to happen. Okay? We are not going to get there with LLMs alone. We want models that can perceive the world the way we can perceive the world. The reason for that is because words don't capture everything in terms of knowledge, description, so on and so forth. So we want the models to have perception. The next thing is we want them to be able to autonomous to the extent we want them to be. We want them to be able to plan. And last but not least, we want them to run on the edge. The model shouldn't depend on some trillion-dollar cluster that is controlled by one nation or one company. It should be able to run inside Daisy. You saw Daisy in the afternoon earlier. She's very cute, but she's a bit slow. She could be much faster, and she's going to get much faster. So let us see how all these things are going to come true. So first, multimodal AI, and natively multimodal AI. So I'll explain what is the meaning of word native in this context. So Alexa, Amazon Alexa, towards the end of last year, announced this generative AI experience. So Alexa, first of all, is going to be far more expressive. She's going to be sad, happy, giggly, all those things. She's going to be able to have open-ended conversations with you. She's not going to say, I didn't understand that, or I can't do that. She will talk to you like an intelligent human being does. She's going to have very good vision as well. The features are in preview already. And all this is possible because of multimodal, or rather natively multimodal AI. There is a QR code. If you want to know more about the underlying models, please do scan that QR code. But let me move to the technology. So first of all, I want to prove to you that multimodal AI is extremely valuable. So there was this gentleman. He posted this when GPT-4 Vision was launched. And kudos to OpenAI for being bold and launching this product first, although there are a lot of great options now. So this gentleman was about to park his vehicle at a place, and in past, he ended up paying fines for parking there when it wasn't permitted. So what he did is, he took the picture, he posted it to GPT-4 Vision, and asked GPT-4 Vision whether he could park his car there, and it's Wednesday, 4 p.m., to give it the context. And it gave a great answer. Okay? If you wanted to do it by yourself, you would have to read everything very carefully. You might make some mistake, and you may end up getting a parking ticket. Just a funny example to begin with. So let us think about this thing, right? Why multimodal AI works at all? We know by now it works. We use it with Claude. We use it with GPT-4 Vision. Some of you also have used it with Gemini. But why does it work at all? Okay. Before we go into that, let us go a step behind, and let us talk a bit about transformers and attention. So all this revolution was launched after a paper called as Attention is All You Need. So what is that attention? Let us quickly take a look at it. So there is a statement on the screen, flesh is old, but spirit is young. What is the meaning of this statement? Flesh is old, but spirit is young. If you gave it to the older translation model, it would translate something like this. Meat is bad, but vodka is good. Okay? Because it used to go literally word by word. The reason that mistake happens, and I'm so sorry, the lines are misaligned. So sorry about that. The reason that the problem happens is because attention is not paid to the word flesh when translating the word spirit. If you look at two words simultaneously, flesh and spirit, you will know that it's not actually meat or vodka, but it's about human beings and their energy level. Okay? So attention is a technology that solves this problem. It helps you pay attention to the right part of the sequence to interpret a given data. Okay? What transformers did it, they turbocharged the attention mechanism by making it very easy to implement and by making it very easy to compute as well so that you can scale with help of GPUs. Now, the second thing that we want to review is how the knowledge it put inside LLMs. LLMs are based on transformers, how knowledge is put inside LLMs. So the way the knowledge is put inside LLMs is by giving them a task to solve, and the task is for them to predict the next word, given a corpus of text. Okay? Initially, their predictions are going to be really bad, but when you try it trillions of times and then you do back propagation to adjust the model weights, and if you keep on doing it with hundreds of machines, in 3 months, you will have a model that will be able to predict the next word correctly. And to do that, it would have absorbed all the knowledge in the corpus of the text that is given to it. So this is how transformer-based LLMs are trained. And as I said, they are great in dealing with sequences. Language is a sequence. Software code is a sequence. But what else is a sequence? Is DNA a sequence? Of course. Is voice a sequence? Of course. Music? Yeah, of course. Images? Of course. If you cut images into patches, they can be represented as a sequence. Video? Video is, of course, a sequence. Since all these data types are sequences or can be represented as sequences, transformers can deal with them very well. Now, transformers can handle text. Transformers can handle audio and video and images separately. But why they are able to handle them together simultaneously in a meaningful way, in a productive way? So for us to understand that, let us quickly review the concept of embeddings. So embeddings are vector representation of data in such a way that it is meaningful. So what you are seeing on the screen is a depiction of word embeddings. In these word embeddings, you see the word man and woman are close together. The word king and queen are close together. And they have relatively the same position with respect to each other. Like the way man is related to woman, king is related to queen. Again, this is an oversimplified representation, but you get the idea that concepts are represented as vectors in a vector space, and the concepts that are similar to one another, they fall closer to one another. So this is a great trick that is there to derive meaningful representation of words. What if you have got images in the mix? Okay? So there is this approach called as multimodal embeddings, and they can be learned in a variety of ways. We are going to see one of the ways they can be learned. But with multimodal embeddings, different concepts in different domains that are related are represented in the exact same manner. So here I'm taking an image and a description of the same image. And if you compute the embeddings with the multimodal model for those two inputs, and if it's a properly trained model, their representations will fall very close to one another. Okay? So here, concepts from two domains, one is image and second is text, they are represented in a very similar way in that embedding space. Okay? Now the problem is, you have got LLMs that are primarily trained with text, and then you have got models like vision transformers that are primarily trained with visual data. How do you align those two together? Okay? So the way you align those two together is you take LLM, okay? Then you take a vision encoder, okay? And they are going to represent similar concepts differently in the beginning because they have been trained independently. Okay, so of course they are going to represent the concepts differently. So what you do is you add another layer in between. Okay, so it's called as projection layer, and that's probably the most important layer. And if you train enough, the vision encoder output at the end of the projection layer will end up matching the other input that is there to the model. So this projection layer is the one that makes sure that the concepts align properly with one another in visual space and in text space. And the same concept extends to audio, video, so on and so forth. Again, I'm going too fast, I know that. So what I have done, I have put QR codes for additional reading materials. If you have interest, please get those links from the QR code. So what I want to tell you is multimodal models is not a rocket science. A lot of university students have been able to build great multimodal models. Okay? Now, why it works at all? Why the alignment between vision and text words works at all? Okay? So first of all, as I said, both can be represented as sequence data. Okay? And we keep on training the projection layer that we saw until and unless the representations match. Okay? And that requires humongous compute. Okay? So we know a problem can be solved, but the problem solution takes humongous compute. What has happened in last 5 years, the compute has grown so rapidly. We have enough compute now to almost train any kind of model or any size of model. So there is this Archimedes saying, right, give me a lever long enough and a fulcrum on which to place it, and I shall move the world. Okay? And this is not a joke. It is possible. You can move the Mars or planet of the size Mars if you have got a long enough lever and a fulcrum to place on it. It's basic physics. You will have to push it down a lot slowly, but it will end up happening. The equivalent of it in deep learning or AI is that every problem is solvable, given enough data and given enough compute. There is literally nothing that is not solvable. Okay, now let us check how good these models are. And now I'm taking an open source example because here the theme is decentralized AI, which I greatly subscribe to. We don't want technology that is only available with certain providers. So we want our vision language model, which understands vision as well as language, to describe what is odd about this image. Okay? So let us see how well it does. Again, you can access this demo by using this QR code. The problem is, if everyone is going to access it simultaneously, it's probably going to crash. But yeah, you can play with this demo yourself, upload any image, and ask the model to explain the image or ask any random questions about the image. And in most cases, it will work very well. Okay? This is based on this model called as Lava, which is currently at version 1.6. So the description of image goes like this. What is unusual about this image? The image shows a person ironing clothes on an ironing board that is placed on the back of a moving vehicle, specifically a yellow taxi. This is an unusual and unsafe situation because ironing clothes in such a location is not only impractical, but also poses significant risk to the person doing the ironing. The person is exposed to the elements, the risk of falling, the potential of accidents due to vehicles movement, etc., etc., etc. Okay? So this model works really well, and it's an open source model. But not all is well. While these models also work, they do have a lot of limitations. And the limitations are studied with help of challenging data sets like Blink. So all these data sets are coming to stress test these models. And the more we have these capable models, we are ending up realizing how much more capable human vision is. What is difficult for models is pretty easy for us. Okay? I want to also highlight some work being done by some companies in Singapore. So this is a robot by Kabam Robotics. Again, you can access QR code to learn about their use case and case study. So they are using these models to provide visual understanding to their robots. It runs on SageMaker in Amazon Cloud, but it could be run, of course, anywhere else as well. So if you have interest, please go read this. Now, we talked about vision, we talked about language. What about audio? What about video? So the way you provide LLMs understanding about audio and video is exactly the same. Again, you need to have enough data and enough compute, and you will be able to train LLMs that understand audio, video in addition to images. Again, this is a great paper by a research team at NUS. QR code is there if you want to know more about it. They explain very nicely how they managed to build an any-to-any LLM. Okay, so not just it understands images and text, but it can also generate them. It can generate audio, video, etc., etc. Pretty cool. Okay. Next topic is autonomous agents. Are you familiar with this image? Okay. So this is an image from Stanford paper. So this is the game, The Sims. In Sims, there is a character that is controlled by the player, and that character interacts with all other characters that are not controlled by you. And these characters have got motivations, personality. Somebody is a woman, somebody is a man, whatever. Somebody is a boss, somebody runs a shop, so on and so forth. What they did is, rather than only one character being controlled by human, they decided to have all the characters as programmable. And every character was associated with a LLM-based agent, with objectives, with memory, and with reflective thinking. And they let this simulation run. At the end of the simulation run, they figured out that a lot of realistic interactions had emerged. So people or characters in this simulation were planning Valentine's Day parties. People were inviting each other, so on and so forth. So this paper launched like 700 other papers, and this popularized the concept of autonomous agents. But, the problem is they don't actually work as well as we would like them to work. Okay? So when I was a kid, I used to love Superman, and it was a really sad day for me when I realized Superman is not real. Okay? If you are sold on to the potential of AGI with the current direction of technology, just read these papers, you will cry. Okay? LLMs are very disappointing when it comes to planning. But that said, if you are realistic, if you augment LLMs with other technologies, they can do pretty good planning. So please follow this gentleman on Twitter. He's a leading scientist who studies the limitations of LLMs with respect to planning. And he is figuring out ways to, make them overcome the challenges. Now, let us see, even if LLMs can do only rudimentary planning, even if it is not that great, right? It is still powerful. And I want to show you. All of you know this app, Perplexity. Okay, and if you're not using this, you are missing something great. So please do download this app and try it out. So Perplexity is great because it helps you get answers in a very intelligent manner. So I had this question. I wanted to buy Apple Vision Pro, and I had 3 friends simultaneously in the US in 3 different cities. I wanted to figure out which city I should buy it so that I pay least amount of tax and I save some money. And I had to think about it because this device costs like $3,500, right? If you want battery straps, it goes like $4,500. So even like 2%, 3% saving of tax is humongous saving, right? So yeah, I wanted to ask it. I asked the question to Google, threw 20 links at me. I asked it to Perplexity. What Perplexity did is it broke this question down into simpler questions. First, figure out what is the base price of Vision Pro. Second, figure out what is the tax rate in Seattle, San Francisco, and New York, because those are the 3 cities of my interest. And then compute the final price. Okay? It gave me this great answer. Okay? And it showed me that Apple Vision Pro is the most expensive in Seattle at $3,866. And in San Francisco, it's the cheapest at $3,800. Okay? So here, Perplexity acted as my agent. It broke my complex question into simpler questions, and it got me answers. So the point I'm trying to make is LLMs are really bad at planning, but whatever planning abilities they have, if they are fine-tuned and augmented with knowledge, they can do phenomenal tasks. There is this team at Singapore, Autocode Rover. Again, scan the QR code. Have you heard of Devin? So Devin is an autonomous software agent. So if you give it a problem statement or a bug, it solves it for you. Devin got a lot of publicity on Twitter. Within a week, Devin was announced. These people published from Singapore their paper and open source GitHub repository. And you know what? They beat Devin. Okay? So please do reach out to them if you have interest in their research work. I'm very proud to highlight work from Singapore. I'm also very proud to highlight work that is happening at Amazon. So Amazon also has developed software development agents which are autonomous. They're not perfect, but they solve great many problems on their own. And even if they only work partially, whatever they do, it saves you a lot of money and time. So right now, Amazon is the leader on this leaderboard. Tomorrow, there will be somebody else. But the point I want to highlight is this is an exciting space. Do take a look at it. I'm going to skip this video in the interest of time. But I want to show you this statistics. So using these agents, Q agents, Amazon managed to migrate more than 1,000 Java applications from older versions of Java to the current. Most companies have this dirty secret that half of their code is in Java, and most of it is running in like really, really old versions of Java, because migration is not an attractive task. It doesn't add to companies' top line, bottom line, so people just don't migrate code. But their software becomes vulnerable to attacks. Amazon, of course, had similar problems. So we figured out an AI-based way to migrate thousands of applications from older version to newer. It would have taken minimum $50,000 per application. But with this, it cost just 10 minutes of agent running. In 2 days, more than 1,000 applications were migrated. Again, agents are not perfect, but these are domain-specific agents that work pretty well. Last point, decentralized AI. How do we get there, right? Somebody had a podcast yesterday, $1 trillion data center, $200 billion power plant, and so on and so forth, right? How do people in Singapore and Indonesia and Thailand and Vietnam have access to best-in-class model? And also how these nations maintain their national sovereignty, right? How is it possible? With edge AI, okay? So this is a big llama. I'm a badass llama, Llama 270B. This is the new llama, the smaller llama, Llama 3 8B. Which one is better, do you know? In terms of abilities, which one is better? So Llama 3 was launched just a couple of months back. Llama 2 was launched last year. And you know what? This Llama 3, which is so tiny, is better than Llama 3, which is so tiny, is better than Llama 2, which is 10 times bigger. Okay? So here are the statistics. I'm sorry. Here are the statistics, Llama 3 8B versus Llama 2 70B. You can see the numbers. If you want to read more about this, please again scan this QR code. How did this happen? Why a smaller model ended up being more capable than the larger model? Okay? So what happened was Meta, they violated the scaling law. Okay? So in past, the assumption was 8 billion parameter model can only be able to absorb a small amount of knowledge through smaller data set. They trained it with a larger data set anyway for a really, really long time. Okay? And it worked. So what it means is probably our assumptions about scale are wrong. Okay? Probably we don't need trillion parameter models. Making sense? Okay? This is a humongous achievement by Meta, and that has inspired others to do something similar. Very thankful to them for making it open source as well. So here is a visual comparison. So the 70B model was trained with 2 trillion tokens. They trained the latest version with 15 trillion tokens. And the model is actually much, much smaller. Sorry. OK. So this is one way to get smaller models. How do you get smaller models through other means, which are as intelligent as big models? OK? We don't want smaller models just for the sake of it. We want them to be as big as smart as the big models, right? So the second approach is teacher-student. Okay? So many a times, I love all my teachers. They spent hell lot of time to understand complex concepts, and they explain me them in a very easy to follow manner. So what probably took them for a month to study, I ended up learning from them in a couple of hours. Okay? Kudos to all the teachers that have positively impacted our life. Can we have a similar approach with LLMs? Or any other AI model for that matter? Okay? The answer is yes. If I'm asking that question, the answer is yes. Okay? So there's this trick called as knowledge distillation. Okay? So I'm taking a vision example. I'm not taking as an LLM example, but concept stays the same. You get the idea. Okay? So when you are training vision models, say for example for classifications, you show hundreds of images or thousands of images of cats, dogs, hammer, car, whatever, right? And these are properly labeled images. So for example, the labels will say that this is a dog, 1, score 1. This is definitely not a horse, definitely not a cat, definitely not a stuffed toy, so on and so forth. Okay? So this is the training data set. You train a large model with this kind of a data set. And what large model figures out is this is definitely not a horse, cat, snake. This is quite possibly a dog. But it is also likely to be a stuffed toy. Does that make sense? Okay? The model figured out additional details about the data set. Okay? It didn't stick to what was provided to it by the model builder. So model now knows more characteristics about the data. Can it pass down this knowledge to smaller models? The answer is yes. So the smaller model is trained to match the output of the larger model. Many a times, these smaller models are as small as 10% of the larger model, and they tend to have all the same knowledge. Again, for LLMs, it is done a bit differently. These are great papers. Take a picture of it. I'll share it on my LinkedIn later. OK, so I'm out of my time. I want to leave you with these 3 conclusions. In 2024 and across 2024, we are going to see a lot of progress in multimodal AI. And that is mainly going to happen because of the new data sets that are being published. Secondly, as of today, agents are not perfect, but they are pretty damn useful. And people are working to augment them with external tools to become more useful. And last but not least, the models that you will be using every day that need not be running in trillion-dollar data centers. Most likely, they will be running inside your cars, inside your robots, so on and so forth. So what we are going to get is not going to be perfect, but it is going to be insanely useful, just like us humans. So yeah, I'm sorry I went overboard probably, went over my time. If you have more interest, I have summarized all the QR codes on this slide. Thank you very much for your attention and interest. Hope it is useful. And next year, we'll talk more advanced things than this. Thank you.